Now in this lecture we are going to talk about post-order traversal in case of binary search tree. So as we said before, the post-order traversal works with this logic. So first we are visiting left subtree, then we are visiting right subtree, then we are visiting root node in this case. Now when we are starting from the left subtree in this case, we see that we have another left subtree over here. So this means that the first subtree that we are going to visit is this smaller left subtree over here. Now the logic is same as in binary tree. So in case of binary search tree and in case of binary tree, the post-order traversal is also same. So in case of this binary search tree over here, if we traverse through this binary search tree using post-order traversal, the order of visit of elements will be like this. So first we are going to start from the leftest node, then we are going to visit the right node, then we are going to visit root node, then the right node, then the again root node, then we are going to continue to right subtree, then at the end we are going to visit the root node over here. Now here again, if you look at this order very carefully, you can see that this logic over here that we shown, which is starting from left subtree, then right subtree, then root node, is implemented for all smaller subtrees over here. So this means that for smaller left subtree here, the left child is 20, so we have visited 20 first, then we continue to the right child, which is 40, then we continue to the root. So this logic over here is implemented for all subtrees over here. Then at the end, we are visiting the root node of this binary search tree over here. Now, based on this logic, let's head over to Java and create post-order traversal method over there. Now here, after in-order traversal method, I'm going to declare our post-order method like this. So it's going to be like this. Public void. So the name of method will be post-order. And as a parameter, this one also will take the type of binary node. And I'm going to name the parameter node. So here again, the first thing that we are going to do, we are going to check that if node is equal to null. In this case, we are going to return because we have reached the end of the binary search tree. So I'm going to put over here return. Then outside this if condition over here, the first thing that we are going to do, I'm going to call this method recursively for the left child. So post order is going to be node.left. Then we are going to visit right child. So I'm going to call this method again recursively for the right child. So it's going to be node.right. Then I'm going to print out the value of node to the console, which is the root node in this case. So in this case, we are going to print out the value like this. Now with this, we have successfully implemented post-order traversal over here. So let's see how this is working in practice. So inside main Java class, we have created our binary search tree like this. So basically, this is the tree that is shown in this picture over here. In this picture also, we have shown the order of the visit of the elements in case of post-order traversal. So instead of in-order traversal, I'm just going to call post-order traversal with the root node. So if I run our code, you will see that the order that is printed out over here is same as the order that it is shown in this picture over here. This means that the post order for binary search tree works the way that it should be. So we have implemented logic correctly. Now let's see what's the time and space complexity for this method over here. Now here again, the time complexity will be ON because in this case we are visiting all elements of the binary search tree. Now the space complexity is also ON because in this case we are calling this method recursively for left and right subtrees. So this means that we are going to insert all elements to the stack memory. That's why it will take a space in the memory, so it takes ON space complexity. Now with this we have come to the end of this lecture. So in this lecture we have implemented post-order traversal for binary search tree. Now in the next lecture we are going to implement level order traversal for binary search tree. So see you in the next lecture.